We need to make sure the inequality is solved for y so that we can graph it, right? Stop, please. So if we're talking about this first one, is it solved for y so we can graph it easy? Yes, it's solved for y. So where do we start? We start at the y-intercept of 1. So we start here. And then we go down to right 1, correct? Because of the slope was negative 2. Is it solid or dashed? Dashed. Sweet. Do we shade? Okay, now we need to figure out where to shade. I'm going to tell you a shortcut to shading instead of testing point. Here's another method. This statement right here says y is greater than. Okay, y, the coordinate y, is up or down. The variable y is up or down, right? So if we say greater than y, which one would it be, up or down? If y is up or down. Greater is up or down. Does greater make sense to be up? The values that are more than y on this graph are above what this equation says, or the graph of this equation. Does that make sense? So we want to shade above, and that's kind of a shortcut on trying to figure out which way to shade. Okay? It's a little quick one. Okay, next one. Graph this. We start at positive 3, right? And then we go up 1, right 1, up 1, right 1. Solid or dashed?
Solid.
Solid. That's a great line. It's less than. Y is less than. If we're talking about, we want to shade the graph where y is less than, above or below? For less than. Less would be down, right? So we shade down. Can you guys see where the shaded region is? Can you see that it's right here? Okay, if you can't see it that way, remember there's 2 other ways to do it. You could do it, if you have colored pencils it helps, but if you don't, you can still do it this way. You can shade, put lines down. Okay, and it's still the same spot. Okay, and if that doesn't help you, grab some highlighters, and you can use highlighters. Conveniently highlighters that match the colors that you're using to graph lines. And where they overlap, see where they overlap? I know, doesn't that look cool? I think that looks cool. Or you can do the thing that we just did at the beginning. Okay, I like to do the little arrows because I don't like using different colors. All right, next one. Y is less than 3. We need to graph that line. Where does that line go to graph? How do we graph that line? Start at 3, right?
Yeah.
Yes, sir. Yes, sir. Start at 3 as y. Start at y is 3. Is it going to horizontal or vertical? Does it look like this? Would that make sense if I put a 3 on the y and then I draw a straight line, which I start adding other y's to the mix? No, that doesn't make sense just visually. Why would you put a point there on y and then draw a vertical line? It just doesn't. Draw a horizontal line. Is it solid or dashed? It's solid. Less than or greater than? Or above or below? Because it's less than or equal to. Above or below? It's less than. What's less than y? Is it up or down? Down. So we're going to shade down.
So we don't have to do the test?
Nope. You don't have to. This one, solve it for y. It's a little faster doing it this way, isn't it? Positive 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Solid or dashed? Solid or dashed? Solid. Do we know why it's solid? Because the equal part right there, right? That was a good one. It's greater than when we look at it in terms of solving for y. You can only use this technique if it's solved for y because we're talking about in relationship to y. Up or down is in relationship to y itself. So y we want to be greater than y, which is up or down? Up. If you can see where they cross, that's great. Right where they intersect right there. Okay? Go ahead and do number 3 real fast. I'll give you like 3 minutes to get number 3 going, and then we're going to work on the word problem, and you guys will be great. Keep it up. Hey. All right, here we go. We want to solve for y on each of those, right? You guys did a great job getting this started. Keep it up. So the first one, you get y is greater than negative x plus 2. Okay, so you start at positive 2, then we go, it's negative 1, so it's down 1, right 1, down 1, right 1, down 1, right 1. Solid or dashed? Dashed. Yep. It's greater. Y is greater. We want to shade above because it's greater. Greater means above y. So we go up. Next one. Add 4x, right? Add 4x, not subtract 4x. 2y less than 4x plus 8. Divide by 2. Y is less than 2x plus 4, right?
No.
Yes. Start positive 4. Go up to right 1. Up to right 1. Dashed. It's y is less than 2. Less than is down. So it's this section. Boom. Goes the dynamite. Next one. Read the word problem and identify the purpose statement to get you the two variables that we're talking about. Okay? Read through it. Identify the purpose statement, like what we're actually doing, so we can define the two variables. Go. There are two values you're given. You're given a 3 and you're given a 10 hours a week. The 3 refers to a GPA value. GPA then becomes one of our variables. X would be the GPA, grade point average. The second number, 10, there's another variable in here talking about the amount of number of volunteer hours. That's going to be your Y. Okay, now we're going to wind up graphing this. Okay, X was GPA, so that's down here. Y was volunteer hours. Y was volunteer hours. Okay, and let's start talking about the inequalities that we can write from it. First, the first statement says our GPA is at least 3. In terms of our variable, how do we write that statement? Which variable is that? GPA is at least 3. It's going to be our X. At least 3. Well, X is going to be compared to 3. The GPA is going to be compared to the value 3.0. At least, is that what sign is that? Which sign? At least, we want to be 3 or more then, right? So it's greater than or equal to. That's going to be an inequality we graph. Next, 10 hours a week, at least 10 hours a week. Number of volunteer hours was Y. That's compared to 10, and it says that it's at least 10, which means it could be more than or greater than 10. We also have to kind of take a look at some other information on this, guys. What's the highest GPA you can have here at Geneva?
5.0.
What?
5.0.
5.0, we're on a 5 scale? We're on a 4. You could, but we're actually on a 4.0 scale, so there's kind of a cap at 4. Correct? The unweighted GPAs, there's a cap at 4, isn't there? Okay, so we need to actually write that down. We can go from 3 to 4. Can we get to 4? Can you actually have a 4.0? You can. We have to say that it's less than or equal to 4 as well. You follow that? There's a cap. Is there a cap for volunteer hours?
No.
Kind of. You can't work like 1,000,000 hours. I mean, I suppose you could, I guess. How many hours are in a year? Okay. There's some cap, but it's pretty outrageously high, right? You're not going to volunteer when you're sleeping, so let's not go through the approximation to what the actual cap would be. Okay, let's just work on graphing. So we have to graph these 3 inequalities together on the graph. So, okay, we have X is 3. X is greater than 3, that would be this guy, right? X has to be less than 4, which is going to be there. So it's kind of squeezed. You see how it's going to be squeezed between those two lines? And then we want Y's to be greater than 10, so we have to graph 10. So they're all solid lines, aren't they? And we want it to be greater. So we want to go up, right? Let's go back to why we're shading to the right of 3. So y is greater than or equal to 3. For that to be greater in far as x goes, x is greater than or equal to 3. Greater in terms of x is to the right, isn't it? Less than in terms of x is to the left. That's why we're doing left and right. So the shaded region is actually here. So using that, what's one possible solution? You pick a point in this region. Could be like 3.5 greater than 10, so 13. Could be a point, as long as it's in the shaded.